Hello, and welcome back to Shikshit Acosta. Today we're going to learn how to solve quadratic equations. In this lesson, you will learn how to solve a quadratic equation using algebra and using a graph. And you're successful when you can solve a quadratic equation by choosing and applying a factoring strategy, as well as if you can determine through an investigation what is the connection between the factors used in a quadratic equation and the x-intercepts of the graph. To start off, pause the video here and see if you can solve this linear equation. Hopefully you were able to do that a little bit easily, right? This is just a linear equation. It's just two steps. To solve this, all we have to do is follow those three rules of algebra, which is in reverse bedmass order, do the opposite operation, and whatever you do to one side, you have to do to the other side. So let's say I started with x. It's being multiplied by 2 and then adding 2 to get 14. So let's work backwards. The last thing we did was add 2, so I'm going to subtract 2. And that will cancel it out. And then I have to do the same thing to the other side. So this was the operation I was targeting, adding 2. I did the opposite operation, and then what I did to one side, I did to the other side. And I end up with 12 equals 2x. 14 minus 2 is 12. To get rid of the 2, again, I do the opposite operation. The opposite of multiplying is dividing. And so 2 divided by 2 would cancel out. And then I have to do the same thing to the other side to maintain the equality. So that would be 12 divided by 2, which would give me 6. 6 is the value of x. And if I try to do the same thing with a quadratic equation, I'm not even going to ask you to pause this video here because you'll notice, well, there's a lot of problems with that. If I move the 2, if I get rid of the 2, I still have two terms that have an x in them. And I can't combine them. I can't get rid of this 5 without also affecting this term. It's really, really difficult. It's not so easy. To tackle that problem, we're going to look at a slightly different concept, and then we're going to go right back to it. Suppose you have two numbers that have a product of 0. That means two numbers that are multiplying together, and the answer is 0. Can you come up with some examples for these two numbers, for this pair of numbers, A and B? Pause the video here and see if you can come up with some, and then resume it once you're ready. Well, hopefully you could see that even if you take something like 3 times 0, that could be 0. The value of A could be 0, and the value of B could be 12. The value of A could be 2,944,661. And the value of B would could then be 0. And all of these numbers, when we multiply the pairs together, we always get 0. Can you come up with a pair of numbers that doesn't include 0? Pause the video here and give that a try. Well, hopefully you managed to see that no, we can't do that. If we take any non-zero number like 12 or 3 or 2 million or whatever, and we multiply it by another non-zero number, the answer will always be not 0. You'll always have a certain number of things. But if one of them is 0, for example, let's choose the first one, A. If A is 0, can you find a value of B such that when you multiply them, the answer is not 0? Pause the video here and give that a shot. So hopefully you got to see that, no, you absolutely can't do that. Any number multiplied by 0 will always equal 0. And we're going to use this idea, this notion that two things being multiplied will equal, if they equal 0, then either one of them has to be 0 or the other one has to be 0. And in doing so, we're going to learn about the most useful form of a quadratic relation, factored form. You may know already that the factored form of a quadratic relation looks like this: y equals a times x minus r times x minus s. And its name, of course, comes from the fact that there are three factors here. There is a multiplied by the second factor, and the second factor is x minus r. That's why it's in brackets. And the third factor is x minus s. And just like we saw, if we take a few things and multiply them, if any of them, if even one of them is ever equal to 0, then when I multiply them together, the final answer, the value of y, will also be 0. The product of any factors is always 0. if even one of those factors is 0. So for example, let's choose some values for a, r, and s. Let's choose this quadratic equation here. What are some values of x that could make this factor or this factor or this factor equal 0? Well, let's look at the first factor here, 3. What value of x could make this equal 0? Well, it doesn't matter what x is. There's no x involved in this factor. So this factor can never, ever be changed. Looking at the second factor here, some number minus 2. What minus 2 could get this to equal 0? Well, that's if x is 2. If x is equal to 2, then this would be 2 minus 2, and 2 minus 2, of course, is 0. And if and looking at the third factor, what number plus 5 gets us 0? That would be negative 5. So this would be negative 5 plus 5, and that would equal 0. So let's check whether or not we were actually correct. Will all of this 3 times x minus 2 times x plus 5, will that actually equal 0 if x is 2 or if x is negative 5? Let's see. First, let's check x equals 2. So I'm going to take this equation, or this one right here, and I'm going to plug in 2 for x. So this would be 3 times 0. 2 plus 5 is 7 times 7. 3 times 0 is 0, and 0 times 7 is 0. So in fact, that is true. And if we tried it with negative 5, the same equation, I'm going to plug negative 5 into x. This would be 3. Negative 5 minus 2 is negative 7, and negative 5 plus 5 is 0. It doesn't matter what this one is. 0 times anything will always equal 0. So the takeaway from here is that if you see a quadratic relation and it looks like it's in factored form, so it looks sort of like this, then the x-intercepts, or the zeros or the roots, are r and s. These are the values of x that make the entire quadratic equation equal the y value equal 0. And when the y value equals 0, you're on the x-axis, which is why we call that an x-intercept. One thing to note is that this is x minus r and x minus s, not plus. So x plus 2, if you see x plus 2 as a factor, that actually means that the 0, the value of x that makes it equal 0, is negative 2. And we even saw that here, right? X plus 5, it was negative 5. And when we see x minus 2, it's actually positive 2 that makes this equal 0. To solve a quadratic equation, like we just saw, we can't just isolate x like we do with linears. Instead, what we have to do is make sure one of the sides of the equations equals 0. And then we have to find the zeros of the resulting quadratic. Now that might mean that if the quadratic is factorable, we actually have to factor it. And then each of those linear factors, which the quadratic will now be in factored form, if we make them equal 0 and solve for x, then we have found our solution, or we have solved that quadratic equation. But even if the quadratic is not factorable, we can still take that equation and graph it. And the x-intercepts will be our solutions. The zeros and the solutions mean the same thing in that case. In this example, we're going to find the zeros of this quadratic. So one thing is, it's really easy to identify the zeros because this is in factored form. It's any value of x that makes either this equal 0 or this equal 0. And if any one of these equals 0, then obviously the product of all three will equal 0 as well. So this is our quadratic. Let's look at 2x. We can't change 1 over 2 no matter what x is. So let's look at 2x plus 1. Actually, you know what? That one's a little bit tougher. I'm going to focus on x minus 5 first. So what value of x will make this 0? I think it's pretty obvious that it's 5, right? 5 minus 5 is 0. So that's one of our solutions. What about 2x plus 1? Well, if it's hard for me to guess the number that x is, for example, I might think, oh, the number is maybe 2. 2 times 2 is 4. 4 plus 1 is 5. That's not 0. I could try negative 2. Negative 2 times 2 is negative 4 plus 1 is negative 3. That's not equal 0. So it's kind of hard to guess. Instead, what I can do is I can make it equal 0 on the side, and I can just solve for x because this is now a linear equation. This is a linear factor. So I could say, okay, I'm going to take the 1 and I'm going to remove it by subtracting 1 from both sides. And then 2x will equal -1. 0 minus 1 is -1. If I divide both sides by 2, I'll find out that if x is equal to -1/2, that should make this equal 0. And I can test it out. 2 times -1/2 is -1, and that plus 1 is 0. In this example, I'm going to solve this quadratic equation, and then I'm going to verify my solution. So remember, to solve a quadratic equation, we can't have things on both sides of the equal sign. We need to make one side of the equal sign 0, and this is clearly the easier side to turn into 0. All I have to do is subtract 10. Now, if I did that on one side, I have to do it on the other side as well. And so 2 minus 10 will give me -8. And now I have a quadratic equaling 0. I can tell that this is actually really easy to factor. This would just factor into two numbers that multiply to -8, but add to 2 are -2 and +4. So this is the factored version of this quadratic. And clearly here, the solutions are +2 and -4. To confirm our solution, to verify it, there's two ways we can do that. We can look at a graph, right? So we can bring up a graph on any graphing technology like Desmos, and I can graph this side of the equation, x squared plus 2x plus 2, that's this red quadratic here. And then I can also graph y equals 10, and I can see what points does the quadratic actually equal 10, and I can see that happens right here, and the coordinate there is when x is -4, which I knew. And the other coordinate when x is equal to 2, and I knew that as well. We can also check our answer. We can verify it if we don't have a graphing technology on us. We can verify it just by plugging these numbers back into my equation here. Or, you know what? I like to always plug it into my original equation, not my simplified one. So if I plugged in 2 here, 2 squared plus 2 times 2 plus 2 is 2 squared is 4, 2 times 2 is 4, plus 2, 4 plus 4 plus 2 actually is 10. So that works. That is a good solution. If I try -4, -4 squared is 16, 2 times -4 is -8, and if I add 16 minus 8 plus 2, again, I get 10. So that's how I can find my solutions. I make one side equal 0, I factor the other side, and I look for the values of x that make either of the two factors equal 0. And you can test whether or not you're correct just by plugging those back into the original equation. In this example, I'm going to see when does 18x squared plus 29x equal -3? Well, for any quadratic, the way we make sure that we solve it is we have to make one side equal 0. So I'm going to get rid of -3 by adding 3 to both sides. And that makes it equal 0. Now, I'm going to skip a lot of steps here, but basically through decomposition, I can find out that this equation factors into 9x plus 1 times 2x plus 3. 9x plus 1, when does that equal 0? It's really difficult for me to find out, for me to guess the number here. So I'll just make it equal 0 and I'll start to solve. And I'll do the same thing for this one over here. So if I subtract 1 from both sides, I get 9x equals -1. And if I divide both sides by 9, I find out that x equals -1 over 9. That's one of my solutions. The other solution, I'll do the same thing that I did here. I'll subtract 3 from both sides. I'll divide both sides by 2. And my final answer here is -3 divided by 2, or just -3 over 2. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.